we are going to start show you how to install the Physisorption tube first. Okay. Usually, what I do is to take the empty sample tube first, clean and dry. Okay. So you take the weight and write it down. Then you take, according to the sample, as I show you, if it's micropore, mesopore, or micropore, how much sample you have to take, approximately, okay? 30, 40 milligrams, whatever it is. So you weigh the sample, 4 digits, the scale. You put the sample inside the sample tube. If you don't have a funnel, make sure that you put the sample and just click on it to get all these things down. Then you take the brush and clean anything until the sun. Yeah. Why? Because you have to you're taking the weight, but it's not absorbing. Yes. Okay. Then you clean it. Doesn't matter if you lose some of the sample, because after analysis, after Degassing, you're gonna take the sample weight. So you weigh the tube. Now we have the sample, and by difference you get the sample weight. If we have 4 digits, then you can measure, you can weight very good samples. Okay. Now the next step is how to install the sample tube here. We have the cover. It's very important the cover to be there, okay? And you have the isothermal jacket. This is so important to be dry. If it's wet, it will not, the capillary does not absorb the nitrogen, so you have a problem, okay? So usually we after you finish, you just leave them in the atmospheric temperature like this. They will dry overnight, okay? So you take a sample, the isothermal jacket, and you insert it. Should go like this. If it's too loose, it's bad. Yesterday we have one which was too loose. Too loose means that it's not touching the sample tube, then the temperature. That's correct.
It should not drop like that.
Okay? Yeah.
And make sure all the way down.
All the way down. Then you take this. Just show them how to do 3 pieces.
You have nut, ferrule, and O-ring. So the nut goes first. Then
okay. Just let me show you the ring. The ring is very important to be clean. So what I have to do is just push it like this, and you can see if it has any crack on it.
It should not be cracked.
Yeah, it should not be cracked, otherwise it will leak. Okay, this one is nice. Okay, you have calories or rings. They are very expensive. Okay, because I've seen some people, they just drop it underneath the table and they'll take it out. This costs you maybe about, I don't know, maybe $35 or $40 each one. Okay, there are some Buna N, they're very cheap. It's 50 cents each, but they degas. Okay, so when you apply the vacuum, start degassing. When you do for micropores, they start going up. Okay, you have very bad results. So this one here is very expensive. Okay, so this one has to go around the sample tube like this. It is hard, cannot move. Okay, so it's not loose. Okay, then you have this is called the self-sealing stuff. Okay, as you can see here, you have O-rings and you have 1 and 2 position. Okay, why we have this position? This is bigger, this is larger. The O-ring has to go inside the sample tube, and you have to see it's sealed. Okay, you have to seal. Okay, it has a small spring on side. Okay, the spring has also another O-ring here. Okay, they have a small ball and also O-ring. So when it is up, the spring is pushing the ball up and is sealing against the seal. When you put it, make sure you have that needle, okay, inside. Yes. Some people, they put it like this and they say, oh, well, I have no absorption because it's closed. Okay, so make sure you put your finger is there. Okay, so
by touching here, you can see if it's there or not.
Yeah. Is it there? Yeah, yesterday I showed it to you.
Yes,
okay.
You showed us.
So okay, you know how to put it back. Okay. Now insert this one here, and let's see how it fits. Should go a bit hard, but too hard. Okay, because if it does go very easy, it means this is not sealing. Okay. So anyway, you can look at it here, and you can see it's sealing. Okay. Now you push this one up like this, and you stick it there. But now you cannot put like this because it will not go inside. So you have to take everything out and put it there, okay? Put it like this.
And then you push all the way up until it stops, and then
Yeah, if it's just put it like this, it will not open the hose, okay? You have to push it up. Okay. Only hand tight. You should not use any tools to tighten.
Okay.
This is enough, okay? The second thing we have to make sure we are putting the sample into the ports, in necessary ports. If you have micropores, and you put number 3, you don't see any micropores, okay? The difference between the ports, the micropore has an external and as additional pressure transducer for low, very low dosing, okay?
So micro will see both, but meso will not see the micro.
Yes. See, if you have a micro meso, you can put it 1 or 2, that's no problem. But if you have micro, you can put it number 3, okay? All right. Then you push the P0 tube like this. It should be very close to the sample tube. So we can measure the P0 very close to the sample. When you move it too many times, it can get loose from there, okay? So if then you tighten. You can tell, okay? So now it's hard, but one time it's gonna get loose, okay? So make sure, because otherwise it's leak, right?
Then you will have there 5/16.
How do you know if it was leaking? The P0. Okay, the P0 should be about 760 here. If you get, for example, 720, there's a leak. So what's happening? The oxygen going inside. Okay, so now we have the sample like this. Now we have to install the dewar. You have to fill the dewar with liquid nitrogen. The dewar should be clean and dry.
No water.
Okay, no water. Why? Because the water can change the temperature. Okay, then you clean it as we did yesterday. You fill it up to the rim with this. This is very, very important, okay? When you put the dewar like this and you measure it, the maximum should go up to this rim. If it goes above, you need to take it out. Because some people say, I don't like to lose this small amount of nitrogen. But it's going above, it's going like here.
So exactly at the level.
Exactly this level, okay?
A little bit below is better than
Okay,
more.
yeah. Is less is okay. If more, you have to take it out. Don't leave it
Within
inside.
this range.
Is this range, yes.
So what
Because
will happen if it's more?
if it's more,
Leaks.
with the time, the liquid nitrogen is going to come down, and this part of the tube is going to get warm,
Will grow.
and the volume is going to be 500 times more, and it pop the tube. Okay?
Yes.
So should be very important to be this. Okay? All right. Now you install the dewar.
No, you have to remove them.
مش
Normally you have
جوا
to
هم
remove them.
جوا.
And you should see no ice inside also.
Can we use heat gun to remove this?
When you finish, you just put it down, and just a few minutes, it's just you can see the water, because this is the size they're very fragile.
Okay,
If
we
it's
have to crack.
if you, for example, you heat it too much, maybe you can break
Actually,
it.
it's not fragile. I break them with my hand. They are very
Well,
thick.
they're
The
not
quartz
that.
inside.
It's not that.
The quartz inside very fragile.
Very
Touch it with
fragile,
a spoon,
and
it will.
don't do
Are you
that
talking
again.
about outside?
Yeah, I'm
No,
talking
outside is
Oh, the outside, no problem. It's the inside. Okay, it's the inside.
Keep it aside until it cools.
Okay, if the sample tube fall by itself, no problem, it's floating inside.
Yes.
But if you have a problem with creating pressure, it's gonna right, and you break it, and this is very expensive. So okay, then you have to work very hard to pay for it.
And don't give it a liquid nitrogen shot directly. There you have a filter. Slowly, so add slowly. That's to take a cool temperature a little bit and then cool as long as you want.
Yeah. We have a Micromeritics, a large dewar with a pump, okay? Is be careful with liquid nitrogen. You have to wear glasses all the time. Nobody can fill liquid nitrogen without we have bad experience, okay? Because one bubble of liquid nitrogen to your eyes, then you lose your eye, okay? All right, now install it here. نحن ريال is very danger. Okay, first is our security, our safety. Okay, so machines can stay here, but if we lose our eyes, then we lost our eyes. Okay, so you have to make sure that you have to adjust this until you see that, for example, the tube, because if the tube is at one side, when the door goes up, it will break the tube. Okay, you have to make sure that they are centered inside the oven. Okay, then when we finish this one is very important. That is push it up, because it's going to go up and push against this one here. It is in purpose, because as if you have a lag here, the water is going to come here again. It's going to condense here. If it condenses outside, it's no problem. But if it condenses here, it's a problem, because it's going to push that. Yes. Okay. So this is now is done. So this is how we load the sample. How we fill the file, I already showed to you. Okay, you put the name of the samples. Okay, the submitter, the operator. It's very important to ask the operator. Okay, then when you start the unit number 1 and start the analysis, you have browse unit station. You have to tell which one is the sample. Then when you raise this, if you don't have the cover, it's going to use the shield is out. Okay, it's very important to use the shield. It take you 1 second to put it, but it is avoid a lot of problem. If something is going to happen inside, it goes inside and does not break your eyes. Okay, so and then the system has to work perfectly by itself. You can walk away and finish. Okay, so the most important thing is that the sample tube are centered on the hole. Okay, otherwise it's going to break. So you can make, for example, a small test and make sure it works. Can you show them, for example, you can raise the door a little bit manually. You see here, you just click like this, so you can see the camera. Okay.
Unit 1, enable manual control. Now you will be able to control all the valves here.
Okay, become yellow. If it's become yellow, it's manual. If it's not yellow, it's automatic. You cannot do anything.
Yes.
Okay. It's very important to leave it automatic, not a manual, because just in case someone comes here and during the analysis touch here, the system will change because it's manual. Automatic will not do anything. Okay. So you say if you click on there, you see here it says you rise or stop. Okay. So you see. Okay. So you have to watch it. You come here and see if it is going to click on the sample. You just stop it. Okay. But you see it's not that difficult. Okay. So if you center it like this here, it will not have any problem. So it's measured and is going to be fit perfectly. Okay. So don't immerse the tube in liquid nitrogen yet. Okay. Just raise it a little bit. Okay. Then you can lower it. That's finished. Then you can walk away. Now you can walk away. When everything is okay, then we can walk away. The system will run.
And don't forget to remove the enable manual control. So
okay. You see no yellow anymore.
Yep.
Then you can. So you click here. Nothing's going to happen. Okay. All right, so this is how you load the sample in Physisorption. Now we'll see how we do the Chemisorption.
Okay.
Okay, so now let's take it out everything.
Okay, just one thing. To take everything out, just make sure that the ports are at atmospheric pressure, so you don't pull it if there's vacuum inside.
Okay.
So if there's vacuum inside, remember, we use enable manual control.
Okay.
Right click, set, automatic, and click those and to set atmospheric pressure. Then click OK. Then you open the, for example, nitrogen.
It's usually nitrogen.
So now nothing will enter the tubes unless you open
The valve.
the valves. Okay? So you hear the vacuum. Oh, remember to close the Pirani, this one. No need to hide nitrogen inside, just to the tubes. And to close the vacuum.
Okay, if you try to go to 700, it's going to go to 700.
Normally the analysis by default it will backfill, but in case you saw here there's vacuum, that's how you do it.
Yeah, as I said, if it's under vacuum and you push it up, you can break the tape.
Yes, sir.
Okay.
Then you close the valves.
And you take it out.
And you can remove it now.
Yeah.
Okay?
إني أدور أول شيء.
Okay, the door first.
Yeah, you
They
can
were
practice.
first. Okay. يلا. في زيرو
Okay,
حط
hold.
عندنا بدنا.
Okay, hold the tube.
I believe في زيرو to remove first.
Okay.
It's easier.
Oh, yeah, you can put it as long as you hold it. You break a second one, then you have to pay it. Now you have to pay. You see, you take it is tilt like this. You have to take it straight. Okay.
When there's a holder, you can put it.
Okay. One other things before I forget.
Yes.
Never put anything underneath of this. Okay. Because when the door comes down, if it doesn't stop, and then the motors are and it's burn off. Okay. So never put anything underneath of the. This is called elevator. Okay. You can put things here or there, but never underneath of the elevator. Perfect. Okay. Just let's work very properly. The sample comes here. You clean it and put it back there.
Okay.
Okay. I like the things very clean.
Yes.
I don't like this everywhere. You can lose them, especially the rings. Okay.
I close the port.
You can.
And there's the way how to put it, okay? And open, open.
Okay, and also the ring. Otherwise, they will not hold there.
Keep two, keep it open, I believe.
The three,
We'll use it for...
We can use the chemisorption now. Okay.
3 is for this.
No,
No,
two.
2.
Two chemical.
Two.
Yes.
Yes.
So, second one,
Okay. For chemisorption,
yeah?
you have only one station.
2.
Number 2, and that's the one here. Okay.
This is for
Yeah.
chemical.
Why? Because the chemisorption is a flowing technique. We need to reduce the samples, so it has to flow. Okay, now show them how to do chemisorption.
Okay, for the chemi, we're gonna use the furnace, not the liquid nitrogen, not the dewar.
So-
And we need a thermocouple to measure the temperature of the sample
Yes.
inside.
Very important. Thermocouple is very important because we need to measure the temperature.
Control of temperature.
Yeah.
عبيد بس can we show بس from the software to repeat how to put a new sample at Physisorption, Chemisorption because of the camera, because it's easy for it is directly on the PC. ما دخل شيء.
Okay, after setting the sample tubes and installation and preparing of the dewar,
We install the sample tube. We install the dewar. Everything's okay. Now we need to run the sample. Okay. Okay. Let's click on unit. Now this is this unit sample analysis. Okay. And then. Okay. All right. Okay. Then we get 3 ports. Okay. And then you need to browse for each one of the sample. This is here very important. Don't get confused. Right? So this is, you already have the sample. This is now already done. You cannot select them anymore.
Yeah.
Okay? So when you prepare the samples, they're going to be fresh samples, so you can browse on them. Okay? So let's browse and show them how to browse. Okay, browse and click on the sample you did not run yet. So if it's complete, you're not going to be able to take it. But if it's not analysis, then it will show you no analysis. Then you can select it.
let's say this one.
Okay, this one there. Then the browse second one. Okay, only select the non-analysis, which is not done. If it's complete, you're going to do anything. Okay, then you get here to this is this show you the sample, the density, whatever. If you forget for something, you can add it here. Okay. Then you keep start. Okay, you see start at the end. Me going to start, but don't start anything. Okay, so if you start, then sequentially it's going to run the 3 sample. That's it. Okay. Start. Click at the start. Okay, at the end there. Okay, you click on start, and that's it. Okay, then we said report after analysis. Okay, can you click on this? Yes. You see, you have options. So you have the print, you have previews, or you have to export it. Okay, just leave it on in previews. Okay, preview, you can see it on the screen. So you can adjust the limits, you can do anything you want. Yeah, because you can export it to files, or you can export it to.
Let me hold it. I'll hold it.
Let me get my hand. Okay, so anything is this first here on the screen, and then you can print it out. You can take whatever you like. Okay, so remember you can take it as TXT files, and you can do whatever you like to do with the data. Okay, so always there, and then you can do whatever. I said 85 pages. If you click on printer, the next day you have no more pages. Okay. All right, so you cancel this one here, and we finish with this. Close. All right, so we're done with the Physisorption. خلاص. Now, we're going to go to Chemisorption. Is you have any question about that?
No, it's fine.
I have
Fine.
a question.
Yeah.
In the method, you said that we can measure P0 several times.
Yeah.
Where do we set this?
Okay, go to the file. Any file, you open any file.
The default is at each isotherm point.
No, the P0 versus time. Okay,
P0
you can say measure P0 each
For each isotherm point.
for each point,
For each point.
which is about maybe 10 minutes or something like that. Okay,
For every point,
it's nice to level like this. Any change, it take 1 minute. Okay, any change on the P0 is going to be detected. Okay, and then it
will
will, huh?
will abort if there is a problem. P0?
No, if it's not going to water, but you're gonna see it, you have a problem.
You get S shape.
Yeah, you get a problem with it. You can see it on the adsorption isotherm going up and down. So let's look for one example, and you see in one sample which is done, was complete. And the one which we did today. Okay, let's go down to yes, it is advanced. Let's go to the first page.
This is
But yeah, okay, the summary. Okay, you have to open it. No, okay, this one of the pages we did not maybe explain too very well. Okay, look at the summary and edit. Put summary. Let's see. This is important about the report. Okay, let's have one which is already done.
عملت على
شو
المنال.
سبعة منال يا عبد؟
The one we should.
واحد اثنين منال.
Yeah, the one we did today. Okay, go to down to advanced. Okay, advanced. Okay, go to the report.
لا، نزلها عبد هيدي لتحت.
كلها
كنت مش ايه عمل لها دبل كليك بتكبر كلها. هون فوق.
تبقى صح. كيف صارت
ايش هذا؟
Click on preview. Click on preview. Okay, here we have. Okay, click on the summary.
Yes, هيدي.
Okay, go down. Okay, and click on the isotherm tabular report. Here we have. Here where you can see the P0. Okay, you can see the P0.
We can
Okay.
see the value
Of course.
and the report.
Yeah.
At each point.
Okay, at each point. How much it is?
760 around
760. See,
759.
we are atmospheric pressure. Okay,
Very
so
close.
perfect. Okay, means if you have 760, means your liquid nitrogen is really good. Okay, if your liquid nitrogen is not 77.2 good, will have higher, a little bit higher. Will be, for example, 775. Okay, so in your case, it's perfect. So you see, do you see what it is? Okay,
You have to
finish.
check it regularly, this value.
Pardon me?
You have to check it regularly. to
Yeah,
avoid them.
you can see it on the report. So it is going to report every time take a point. You can see on the screen. Okay. Okay. Let's go again to the summary as we said as before. Let's go back in the preview. One thing is the page I'd like to show you. Click on the file, open file. Open file. Click on the sample we did before.
منال.
Okay, go down. Okay, go advanced. Okay, click on the report. Okay, and summary, and this one. This page is very important on the summary. Okay, you can select automatically what you like to have. For example, I'm not interested about DFT. You unclick it. Okay, but leave everything clicked so you can see everything on the report, and then you select what you want. Okay, now with everything clicked, but you see, for example, for pore volume, we're selecting PRP0 0.019. For the desorption is 0.95. Remember, I told you the first point of the desorption is our total pore volume. But if you like to put 0.4, for example, you can put 0.4. So your total pore volume will be measured as 0.4. But usually the total pore volume is when the pressure is close to 1.
Yes.
Okay? So, but I said if you have very close number to 1, you can have some problem of some condensation. So I think the first point of the desorption is about 0.98. Okay, so you can select it here, and then every time you run the sample, you're going to get the total pore volume at this point. Okay?
Yes.
All right. So you can select anything you want here, but I will selected everything that comes as default. Okay, so you later on you select the page you want. Okay, that's finished. This is very important. So now you can go, for example, again to the report, the isotherm, for example. Okay, click the edit. Okay, here you can, for example, logarithmic or linear. Remember, as I told you, logarithmic is very nice, so we can expand it, we can see it. So leave it like this. Okay, let's see another things. Just close it, okay? So the BET, okay? So you get tabular report, BET transformation, just leave it like this. I would like to see the straight line for the BET transformation.
Linear.
Okay, yeah. It's a difference we talk about the BT or the BT transformation. The BT transformation, if you remember the equation of the BT, the first part of the equation as a function of relative pressure should be straight line. We should see it. Okay? Not only the number, but we should see it, and the correction coefficient should be 0.999. Okay? So these are selected also, you can see them. Okay? Okay, the Langmuir we don't take into account. Okay, the T-plot analysis. Okay, the T-plot analysis is you have to select what? You have to select the total surface area. Remember what I told you, the micropore is not measured. So you have to select the BT. Okay, it's selected. Okay, then you have the T thickness. Which one you like to select? There are several T thickness, but the most important one or the most used one is the Harkis and Jura. Okay, then you select the Harkis and Jura, but you can change it. If someone comes and I don't like the Harkis and Jura, I like to have Halsey, for example. You just click on this and the system calculate everything according to the Halsey equation. Okay, finish. So for each one of those, so you click on the T-plot. If you did not click on the T-plot, don't care, because after you finish, you can always select it.
Yes.
Okay, you don't lose anything. What you cannot repeat is adsorption isotherm. Anything after that, you can change the T-plot, you can change anything you want. Okay, so everything's the same. Okay, so anything you click on it, you can edit, you can see what it is selected. All right. Okay, this is finished with this. I think it's enough. Okay, now let's go to. Do you have any questions about this?
It's clear.
It's clear.
Just the total pore volume we get it from the T-plot.
Total pore volume for the adsorption isotherm. This is the first page of the summary. We selected a 0.98. Total pore volume.
Point after
The micropore volume is from the T-plot.
micropore volume from T-plot.
Okay? The T-plot only for micropores.
Yes.
Okay?
هيدي ما فهمت كيف علقت فوق.
لا بنزلها ده اصلا.
لا على بالك شيل السكيماتيك.
Okay? Go File, Open, new sample. Okay? Then you have to select which one you like. Physisorption, Chemisorption, or dynamic. Okay? So Physisorption. Okay? Now you have the first page. So you have the sample, okay, the name, submitter, operator, and then the weight of the sample. You can leave the weight 1 because you don't know the correct sample weight. So if it's 1, then you have the density. If you like to use the free space with the density, you can let's select the density. Otherwise, you leave it in 1 and you measure the free space. Okay? Then you select automatic, collected, or manually. I explained to you when manual and when automatic. Automatic is going to do it, everything's here. Manually, if someone has run the sample somewhere else and you would like to see it according to your program, so you code manual and then you will have a, can you click in manual? Abed, can you click in manual modes? Okay, then is when you go to this, the analysis condition. Okay, you see here you have to enter the pressure and the volume absorbed. Okay, so you have to have the data from another sample. Okay, you have to collect the data and the volume from the samples, and you start entering there. Okay, okay, go back and change it to automatic. It's okay. Okay, because it asks you, do you like to change it? Okay, so now you put the comments you want, whatever you want. Okay, go now to the gas condition. Okay, the gas conditions, as I said there before, we have two parts, two options. Okay, the first one to go to 100 degrees C or 90 degrees C and degas a sample to take the water out. You stay 30 minutes and then you go to the second one. You can ramp it, usually 10 degrees per minute. Okay, so you can degas a sample for 1 hour to whatever you like. Okay, you select it from there.
This is in situ degassing.
In situ degassing.
After doing the degassing here,
It is here.
This is only
Yes,
for
Only
micro.
for
micropores,
micropores.
Only for
Yeah,
micro.
but the sample has been degassed first there.
Yes.
To be
Okay.
done with it.
Yes. Correct. Okay.
And you specify the temperature and the heating rate and and the time.
Okay. 10 degrees per minute, not more than that. Okay.
So this is here we specify the end temperature.
But how we can tell it to stay at 80, at 100 for
Eh,
30 minutes?
Here, time,
For 15 minutes, let's say, or 30 minutes.
30 minutes.
whatever you like.
على 100.
Where the red?
Soil will be 100 and the rate 10 degree per minute. for
Okay.
15
And for
So-
other step we put insert and we put the
Yeah.
Pan,
Yeah.
pan will do after.
pan
So
down.
you go
Yeah, the second step. The second step.
200 for example.
Okay.
Also 10 and stay there, let's say
1 hour, 60 minutes. Okay. You can select the time you want.
Yes.
The one condition is that the maximum temperature you like to go is the temperature at which your sample has been calcined. It's very important. Remember what I said. Otherwise, you're gonna contaminate your.
Decompose and go on.
You're going to contaminate your manifold. Finish.
So you don't exceed the temperature of, you mean, the of gassing. Okay.
Yeah. So this is why I'm asking you, if you don't know, okay, you have to put it over there first. You degas it 400 degrees C, then when you come here, if you like to put it 350, it's okay. But never 450, for example, here.
Yes.
Okay?
Sorry, but here we have to run the degassing.
Only for micropores,
Yes.
okay, if the sample has not been degassed over there. Okay, then you have to-
How do we run it? Or when we.
Here, let's start.
start.
You put your sample there, you put the, do you like to, let's put the heating mantle.
But I think that this one is for the smart vac prep and not for the in situ.
Oh, this is connected to the system? Okay, let's see what it says.
Smart vac evaluation.
Oh, it is for-
smart vac.
If it's that one, sorry. Okay.
The in situ.
It's for the
will be
analysis
done
gas.
in
In the analysis.
conditions,
Yeah,
in the
sure.
preparation-
Thank you.
The preparation
Yeah,
phase.
yeah. Here. Okay, there's two pages.
What is the degassing then? Here?
The degassing for the first says
Yeah,
go back.
Go back.
One- This
Go back,
you
Albert,
should not use it because we don't have the smart vac prep.
So we don't put
Smart
it here.
vac prep
No.
evacuation.
Yes, you don't have the
You
smart.
just unclick it.
Yeah, we don't
it
do
will not
anything.
be used
It
anyway.
not be used. It's not
Whatever
gonna
you
take
put
into
here, it will
account.
not be
Yeah,
used.
Okay.
it's the second page. Sorry, sir. Yeah, okay, now here we go.
Preparation.
Okay, now. Okay, it's the same thing. It's the same way.
But the
Exactly the
same
same way.
view.
The same view.
Same view, but
Okay.
Different option.
different
Yeah,
option.
it's not. Probably we don't have the smart. Anyway. All right.
Okay.
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 So here when we start the sample, there is a step of degassing.
You will put this first, not the tube.
Let's do it.
And we do it manually, and then we remove it and put the door.
Yes,
It will finish
tell
this
you.
step. It will tell you
It will tell
preparation
you,
done. You can remove
Okay.
it.
Without this, just put the sample tube. Okay, don't need to push too much. Okay, so this is the way how you install the heating mantles. Okay, you have the thermocouple and you have the heating. Okay, show them how to put this. Okay,
So this goes-
from there like this. Okay, if you push it down and move it, it's going to lock there. Okay, lock and unlock. Okay, you put it there and show to them how to
So
put
the
it.
hub should be facing you, and you can read it and go from below.
Okay, now just put it over there. Okay, you locked it like this. Push it down and lock it. Let me say, you can just push. Yeah. Yeah, they don't have to, okay? Easy, lock and lock. Okay, just leave it there. Leave it there so we're gonna put the heating mantle over it. Okay, push it down and lock it. Okay, this is can move like this. Okay, now you move the. You put,
And then you just remove it from this way. The sheet goes beyond it.
oh yeah, you can keep it.
We can keep
You can keep it. Yeah, you can keep it if you like.
The instrument will not allow you to do analysis.
Exactly.
You have to take this out.
For Physisorption?
We take this out, but we can keep this
The
one.
Yeah.
tray.
We just unplug it, right?
Yeah, you can. Yeah. But it's anyway, it's very easy. Very easy to.
to avoid the confusion with
Okay,
the user,
okay.
we keep it there.
Okay.
We use it.
When you do Physisorption, when you start, it's gonna ask you to take it out. Take the heating mantle out. Okay. So, but how you put it there is
So
very
this is
easy.
a connector for the
For the power,
power, and this one for the.
thermocouple. Thermocouple goes there, and the power says no confusion,
No, okay.
Okay.
And there's a clamp. So
like this. Okay, then when you start heating here, it's gonna start heating over there.
Now when it's connected, you will see a window for the mental, the temperature, and the target, and the rate.
Okay, and what is nice about it, if you like to change the temperature, you can change from here. Okay, so don't have to go inside the software, you just can change from here, because sometimes
From the
it
manual
overshoot too
control.
much. Okay, you have manual control. So maybe it says you're 400, I went to 420, I don't like this, you can lower it there. Okay, so now you take it out.
So Simon, so it is if it is in the analysis, so it will be doing we were doing degassing at the first stage. So the software will tell us now install your sample inside the heating mantle. And then
No. This is manual. You have to put it there,
Manual.
and you start heating, and you put certain time.
Okay.
Okay, it's gonna follow your heating at certain time. Once it's finished, you're gonna have a warning
Okay.
that's either it's
To remove
finished
the-
to take it out.
Okay.
Okay. Of course, when you take it out, you have to wait until it's cool off.
Okay.
Okay, and then you remove this. You can leave this as a wash. Okay.
We put the nitrogen to it.
Then you put the wash in it, and
we
you
click,
start. Yeah, and
start.
it's resume.
Resume.
So usually هون بيكون في الجاكيت صح؟
Yes, it's my jacket.
But we have to put it out. Up.
Yes.
Okay.
When you heat this one here, okay,
This
if
one-
if the
this
thermo,
one.
that's right, should move it like up, okay. Otherwise, if it's down like this here, it will burn here. So as if you just put this way, it should be sticking inside, so it's not loose.
Yeah.
So you can push it up and stay here, okay. Then you can put the heating metals here.
Let's put it for demonstration.
ايه demonstration.
هلا بدنا نحط المانتل ولا لا؟
Do it. They can see it.
حطها
عشان
حطها
الفيديو.
شيلوا حط هيدا.
حتى not to be confused.
I understand this is the first time is a bit.
هلا انا بفتح هذا اللي تصحى
حطيت. هاي مش مليحة.
هيدي هلا بتاخذها معك يا عبد.
في اثنين مش منيح.
هاي اللي معي.
How many you have here? How many do you have from the? We owe you one. ليش ما قلت لي؟ كنت جبت واحد معك.
على هيدا مشي حالك مشكلتي باليونيفورم هيدا مشي حالك
هاي خلص الحمد لله.
الحمد لله. So where don't you owe you anyone?
What you ask a lot because
Oh, that's a lot.
we still for 4 months we still did not launch the instrument operation.
But the system worked very fine. You saw how nice are the results.
Has to be all the way
Yes,
up.
all the way up
Yeah.
when you heat with this.
Yeah. Otherwise, you will burn off. But you can push it a bit higher, okay? Because it's too high. So you just push this one up. عليها شوي.
أنا كل sample inside.
Yeah. Just lose a little bit. Push it down and okay. Okay. It should be very close to the bottom. Okay.
هيدي على وشك انه
Don't tie too much. Okay. You cover it.
Sorry.
Okay. Done. Right. This is the way you have to degas the sample in situ. Correct? Is okay?
So we come here to the software and we say what?
You can go to manual, unit 1, enable manual control. Right click set. Let's say target to 90.
with a ramp rate of 10 per minute.
10 degree per minute. And you click
Press
OK.
And it will start heating.
You will see
at the
target
rate.
91.
And you can see it heating. Okay. That's right. You see at 10 degree per minute, and you leave it for a minute to see if it's heating, does heat or not. Okay.
First you will See you feel the heat here, and then you will see this goes orange.
Okay, just let it heat a little bit. Okay, let's start heating. Okay, already started. Okay. Okay, it's already 21.5, 21.6.
Degass it now.
And you can open the vacuum also.
Okay.
You have to degass it.
Yeah, because the question is why we're doing this is because we would like to degas the micropores here. Okay, so you need to open the vacuum. Okay, so you open the vacuum, this one and this one here.
Port 2, the vacuum.
Okay, so let's say is this port 2? They open up port 2 and you degas it.
الفاكيوم هون السامبل هون سو بتفتح هيدا وهيدا وهيدا بس
When it's green is open, when it's yellow is closed. Okay.
Doing it manually.
Yeah, because you're evacuating manually. It's just in situ. It's like that. Okay. So it is manually because you selected manually. This is just an option to clean the samples for micropores only. Yeah, it's not something for very often. Only for your sample. You have to do it for your sample. Okay. But you see, in your sample, we run it without doing anything like this. Okay. Sometimes when we have very ultra micropores, when you have, for example, 4 Armstrong, 5 Armstrong, it's difficult to clean over there. You don't have too much vacuum over there. We need to have apply very high vacuum. Then you put the samples here and you degas it. Okay. This is an optional thing. If you had high vacuum over there, then you don't need this. But in the case you don't have high vacuum there, so you need to have it here. So it's an optional stuff. Okay, we need to stop it because it's already heating up. Okay, so this is the way how you stop it. Okay, you just put the temperature at 25 degrees C and you stop it.
هو احسن شيء الواحد يعملها مانيولي وبعدين يعمل الران الاناليسيس وخلص.
As you wish. It's only a few cases. If you have ultra micropores, you need to, because it does not have vacuum over there. So you need to clean the sample very well, so you do it here. Okay? Okay, then you close the valves, and the system will continue doing everything. It will open the valves, it mix. So the only option manual is just to heat the sample and clean it from extra water in the micropores. Otherwise, the system will continue automatically. Okay? Then you lower this.
بس هلا جوا وبرا.
Just بس هلا جوا.
إذا ما تعلمت.
هتعمل له تريننج ها؟ بتعمل له تريننج.
نزلها مش حطها على ضرب.
anyway هيدي ما بدها ترين
خلص بدك تشيلها
لا
لا.
بدك يخلوه
خليها ما فيك بدك تعليها بعد اكثر.
انتبه البي زيرو بس انتبه البي زيرو.
بدنا في زيرو.
The way is not actually شوي.
شوي عكشي ها؟ Okay.
ناكد انه ما عندنا تنزل.
Take the heating mantle out. It will not start. The nozzle will not start if you have this one on. Okay. It will tell you that the heating mantle is there.
شكرا هيك خليك تعمل.
Okay. Then you can remove this if you like, but at least now this you can.
Wait until
It's cool off.
it's cool off.
Okay. Then you lower this. Don't forget to lower this.
Yes.
Otherwise, big problem. You lower it and you put the door and you start the analysis. Okay. Okay. All right. Any more questions about the Physisorption? I see you, so you are a bit, I don't know, worried about it.
No, we're not worried. But we are talking about this one should be installed first. Yes.
Yeah.
I know.
Okay.
But, for the video.
Yeah. Don't forget to put it.
Sample and,
Yeah. Don't forget to put this. It's very important.
This one should be here first and hydraulic. Okay, installed.
Yeah. This is now the Physisorption. But I don't see if there's any question about Physisorption anymore.
No, it's fine.
It's fine. Okay. Let's go for Physisorption. Okay. The first thing is we need to take the sample tube out.
Yes.
Okay. And the sample tube should be atmospheric pressure.
Sure.
Okay. So by that smart dosing, you tell it what pressure you like to go, 700, it will do 700 and stop automatically. Okay, now remove the sample.
Please don't lose this, ما في غيره. اوكي الاورنج اتس اوكي في 3 4 بس هودي ما في غيره. ما حدا ياخذهم على البيت، ما مين عاوزه.
You'll be amazed.
No, they will not take it. The only thing they can drop. Okay, sometimes they drop into.
Yeah.
Just to have to move everything and find it. So.
خلص بس يحطهم هون.
المفروض دغري يسكرون فوق يعني directly.
Now we're going to go from glass into quartz.
So glass.
Okay? Now you have to use close. If you happen to touch by your hand, before start heating, you need to clean it with acetone.
Acetone.
Okay? It's preferred not touch it to your hand.
gloves only.
It's come with gloves. Okay? It comes with everything.
It was an operator?
With the operator too.
Except the regulators.
Except the regulator. The operator you have it here, so it's just called Abed. You have the best operator ever. So,
So now we want somebody who knows 7 languages.
oh,
Include you.
this. Then you have to learn other languages, Spanish, for example.
Okay, this is the tube for the.
This is very, as I said, very expensive tube. Okay, really very expensive. Okay, Abed owe you one. He has what the one I brought was me.
Yes, I take 1 kilo to for the micro.
Okay. The same things. You wait as an empty sample tube. You pour your sample as we did before. Exactly the same things. Okay, and then in this case, you ask the catalyst that has been calcined. Usually the catalyst is being calcined. Okay, then you have to store it there. And the first thing is to reduce the sample with hydrogen. The first thing, the first step. Okay, so let's load the sample here.
So can we first, Abed, can we make a demonstration how to put a sample because there is a glass wool and
glass wool sample.
just a very quick
Okay,
demo.
is if you are using pellets, there's no need for the coarse wool.
Okay,
Why? Because as you can see at the bottom, it's just
a very small.
yeah. We did it on purpose, so it's like this. Okay. Here we don't care about the free space, but after this is this very tiny and small bore. Why? Because we need to respond very fast. If the volume is large, the peak will be very wide. Okay, so we do have a peak very wide, and you like to integrate. The larger the base of the peak, the worse will be the integration. You know that. Okay, so we need to have very narrow and very sharp peak.
As for the ports, I've run an analysis on 1 and 2 for ZIF. Gave me very high surface area, port 2. Gave me surface area of 1000. So how is it for Physisorption?
No, we use this port for chemistry just to fit the tube. The tube will fit like this.
Ah, we can use it also for Physisorption.
Yeah, it is for Physisorption and chemisorption.
It's just for the design of the tube to fit. It will not fit only on two.
So it's not specialized for cooks.
ضيعت كل الأسئلة.
It's good. All right, so let's do it. Okay, just put some sample. Do you have a reference material?
I'll put the silk aluminum because now it's easier to pull it out. Just for demonstration.
Yeah, okay, that's fine. Put any sample there. Just show the camera how you put the sample. But you should have.
Glass wool.
But you should have a funnel there. This is the funnel. Okay. First, let's wait. First, you have to weigh the sample too. Okay. So you have the scale beside you. No, don't take your.
I'll take the other one. This one, I will not be able to.
Again here, the sample weight is after analysis. Okay? So empty sample tube, weight.
لا بدي تبع حكيم اسنان.
تبع حكيم. What
حريري
حكيم؟
هيك
It's a tool like the dentist.
Long metallic. That's it, the glass.
حكيم سنان.
Yeah.
هذا تبع حكيم اسنان.
So now you have a patent on it. So the حكيم سنان. Okay.
Okay, let's take the worst case scenario. If we have powder, okay, first we're gonna use glass wool.
Coarse wool. It's a
Coarse
coarse
wool.
wool. Okay. No, you are working the wrong way.
Why?
Okay? The coarse wool is so dangerous.
Under fume and
Okay. You can use under fume or way out from you. Okay. The small broken stuff you can inhale it inside. It is very dangerous. Okay. So please don't use it like this. Take it under the hood or you just take it away from you. Yeah. Little small amount of stuff.
Very small.
Little bit small just to cover the chip in the bottom. Go away. Go away. Push it down. No, push it well in the well. Okay.
compact it immediately.
Yeah, compact. Yeah.
Okay.
Okay, because if it's not compact, it will, when you float, it's going to come up.
The flow will come from the small one to the big one.
From the large one to the small one.
So
Okay, but sometimes apply vacuum after flowing, you push it up. Okay? Is the flowing the problem? But when you apply vacuum, because remember that after reduce, we apply vacuum to take the hydrogen out. Then if it's loose, it will come up.
But what if some small pieces they
Debris.
got some debris
It
form?
will not react.
Yeah, I mean it will go into it will get sucked. Or it will go into
It doesn't matter if it gets sucked. You have a filter on the valves. Okay, if you have a clogged filters, it gets, for example, you can see a high flow and pressure goes up. The system will warn you. Okay, so but usually if you put it well at the bottom, it will not come out. Okay, it's too much coarse wool. Too much coarse wool. Okay, it's less because it has to go inside like this. So you can use less than that.
You know why? Because now they need to add very much sample because the probe will lie here and it should be in the middle of the sample.
Yeah, but
right?
it doesn't matter because the temperature from here to there is such a small chain. The temperature is not too much. It's just maybe 0.2, 0.3 degrees. It's not big deal. Okay. So anyway, make sure that the coarse wool is really cold. Okay. Otherwise, because remember this when we do flow, no problem. But when we apply vacuum, if this is too fluffy, it's gonna come out. Okay. All right.
Let's use that.
Okay, then you wait. Now you can weigh the empty sample tube. Okay? So you weigh the empty sample tube, you take the weight, you put your sample inside, and you're ready to go. One thing is this, all the samples should be down. If happens you have some powder, very fine powder, and sticking to the tube, and you don't like to lose it, you can make a ball of coarse wool and push on the top. But then you need to take the weight of the ball. Okay, what I do here is if I have, for example, powder, then I make a ball of the coarse wool and also weigh it with the empty sample tube. Okay, I put beside the sample tube, so I have everything. Okay, then I put the sample and then I put the ball and push everything down. Should all the sample be at the same level? Okay, so it will get the same temperatures. Okay, so we'll not have a gradient of temperatures. Okay, we finish with this. This is the way how you weigh it.
Then you
Okay.
weigh it empty. This is the support.
Okay, you pair it between 0 and you weigh it.
The wool would stay in the tube during
Yeah.
the analysis.
Yes.
So shouldn't we run a blank for the wool?
That's the coarse wool is that we've done it so many times it does not absorb anything.
So you're sure.
Yeah, of course. Otherwise I
know,
will
but
warn you.
I thought each user should do.
No. Okay, the sample tube should not touch anything. Okay, so you take the sample weight, the empty tube weight. Okay, as I said, if you have a ball, then you have also to weigh it.
Weigh the previous.
Okay. Then you put your sample, more or less you weigh it 0.6 or whatever you like. Okay. Remember the Physisorption, the quantity is very small. So you have to take enough samples, not like Physisorption. You take maybe 0.4, 0.5 gram. Okay.
In the Physisorption, you take
More sample than Physisorption.
Grams.
Yes. Now 0.5, not gram, not 5 grams, it's 0.5.
500
Okay, this is the way we put it.
Okay.
Okay. Now in this case, there's no isothermal jacket because only for Physisorption. Okay. All right. Let's continue here.
And is there a certain height for the sample?
No,
to
no.
fill it?
If you have sometimes we have very fine powder.
Yes.
Okay. And if you have it too high, then you have back pressure. So you have to drop the pressure.
Okay.
Okay. Only in this case you have to fluidize the bed. How we fluidize the bed? We use coarse bead, very small beads of coarse, and you put it there first, and then you put your sample. Okay. Then you have no pressure, so the gas can flow very easily. Okay. Only when you have very fine powder and you lose a lot of samples. Sometimes people, for example, the adsorption is very, very, very low, and you need to use maybe 1 gram of sample. Okay, so we need to fluidize the bed. Otherwise, we'll have a drop in the pressure, and then you have a problem. So we cannot reduce the sample very well. So I have a small glass beads like this. Okay, I just put some glass bead, put the sample, and after I finish, I just sieve it. Okay, the sample will go, and I can recover my glass beads or quartz bead. Okay, the glass bead can go to 400 degrees C. So, and your reaction is over 400. So no other sample can reduce more than 6.
So,
if you like to go to higher than 400 degrees C, you have to use quartz bead.
sorry,
Yes.
Simon. So you put these beads only if you have a very, very fine particle?
Very fine particle.
So that to prevent it from what?
Yeah, if you have very fine powder, when the flow, you have a drop in the pressure in sample too. Okay? Because the flow cannot go so easily through the sample, and you have too much sample, then you have to fluidize. It's like fluidizing catalyst bed, the same thing. You fluidize it. Means that you put something so the gas can flow so easily through the sample bed.
Okay.
Okay? This is called catalyst bed.
And
In catalysis, we call it catalyst bed.
do you have these beads here, or we have to
No.
order?
No, you get it somewhere. We don't
You don't
supply.
supply.
On third
Okay.
party.
Okay.
Okay, and when do we use this filter, small filter?
Okay, some of them they can put it at the bottom. Okay, you can,
It's better.
I never use it, but I say it because some people say I like to have a filter. You can use a filter if you like. So you push the filter first. So in this case you don't need to use even a glass wall. But with the glasses it's just to hold it. Okay, but we send the filter, but I never use it. Okay, he's asking about the filters. You see, I have a small bag of filters. Show it to them. Okay, the filters has the same size as the sample tube, so you can push it down. Okay.
On top of the sample.
On the bottom of the top.
the bottom.
On the bottom, also the
Before
top.
the wool.
Also can be the top. Okay, instead of the glass wool, the ball, you can push this one and push all the sample down. They have exactly the same idea of the sample tube. Okay, but it's so difficult because when you push it down, it can go like this or like this. Okay, you push it down like this, so it can push everything down. But the quartz is much easier. If you put a ball pressure, everything down.
The quartz ball.
Okay, why don't you try to put one? Okay, let's try to put one on the top.
Sorry, Juan.
Okay, it's not that easy.
So we have to cover the sample
It's not
with
necessary.
a ball or
You
with
see how-
Maybe if it is a powder, you should.
If you can have the tube like this, it's to be 1/8 of the tube, that size, it fits perfectly there. So push everything down.
Can we put the glass wool instead of
Glass wool?
sorry,
You can do glass
quartz
wool.
This one we will put on the support below.
Whatever you like. It's just to prevent the
Back.
sample to go down, to go through the sample tube. This is any way you want. Okay.
But we have to cover it,
Well,
or we don't.
because remember the gas going like this.
Yes.
So
Okay.
we don't want it to
So it's not gonna come up unless it's and a vacuum. Only you can push the sample up under vacuum if the sample has water. Okay, it is wet because the water is gonna come out under vacuum and push the sample up. Otherwise, the sample will not move. Okay,
So we don't have to cover it every time.
it is there. Some people like to use it. It's available. Okay, but any case, here and there on the valve up there, you have filters. Okay, they're very 20 micron filters. So in a case you have any problem and the sample powder goes up, it will stick on the filters. Okay, so it will not, they will not go inside the manifold. No. Okay. All right, sir. Go.
Okay, The same nut and the ferrule that goes for the Physisorption
the
will
same
go for
one.
the large side.
Okay, so the same tube and the same O-ring, the same fitting.
Okay, for the other side, it's already here.
Okay, and one thing is it moves. You see that once it's moved is the purpose. Okay, because if it does not fit exactly, the people try to push the sample tube and break it. Okay, so it moves, so it's loose. Okay, it's in purpose. Because we got some people said, we have this loose. Well, this is a purpose. This is what is loose.
Okay, please don't lose this blank. So
Okay, you see it's the same way.
principle. Nut, ferrule, and O-ring. And it's conical.
The smaller than the other one.
The conical part should goes in.
The reverse, down.
So, nut. The conical part of the ferrule should go down.
If you put it on the top, at the reverse, it will cut the O-rings when you tighten.
Okay, and then the O-ring. Okay.
Alright, done. Alright, now you install it.
All the way up.
So this one is fixed. The other one is loose. So first fix the other one, which is good, and take that one. Don't over tighten it. There is nothing. Now we have the samples installed. Now we have to install the oven, the furnace. No, the oven.
Thermocouple.
It's going to go there.
Okay. There's a guide here, the two pins here. They should fit here. Okay, so the furnace doesn't move.
Okay, one thing is important that we heat up the oven according to the sample temperature. It's not the reverse. So whatever you see is the sample temperature and not the oven
Not the
temperature.
oven.
Okay, maybe the oven is maybe 15 or 20 degrees above. Okay, but what we see is the sample temperature. So we control the oven by controlling the sample temperature. Okay, so we are sure about the sample temperature. Okay, you see you have to cover it now instead to other ones, which is this one here. Now you have ceramic. Okay, and the ceramic has the same shape of the sample tube. What else?
الشنطة
The clip, the clip.
Sample the roll and the clip.
المفروض يكون على الطاولة.
Okay.
So this is the thermocouple for the sample. Also has a clamp and goes here. Then
Does-
you pass it from here. And it should stop here on the bead here on the tube.
A small pocket there,
Okay?
very close to the sample.
And there's this clamp to hold it to the tube.
Be careful how to do it, okay?
Why is ugly? Why is ugly? Why?
Because there is a probability that you can crack the
No. No, just open it and make sure this is just hold it.
Okay, just make sure that the thermocouple just lies on the bead here. As close as possible.
Take the temperature.
Okay.
And the clamp should be high.
And then put,
Yeah, otherwise we'll go inside the oven.
put the power here. And this goes to
No,
the...
you cover it after you raise the sorry, you cover it. Okay, you put that one
So it's putting the thermocouple
for the oven, yeah. Okay? Okay? Alright, let's explain. Can you hear? Okay, we have the heating elements. the thermocouple and the cooling system. Okay. Okay. Let's change now the configuration. I need this place just to talk. Sorry, a little bit like this.
Okay, just we want to switch the view from Physisorption to Chemisorption. You go to unit 1,
مبيني عندك مبيني
chemical adsorption. Okay.
So what did happen? Now, number 2, you can see the sample tube as a U-tube, the flowing technique, and this is the oven, and 1 and 3 are empty. Okay, you're gonna choose them only number 2. Okay, that's it. Now we need to raise the oven, make sure the sample tube is going inside. You do the same thing manually.
So again, unit 1, enable manual control, and right click here, raise.
Okay, just make sure you are close by, just in case. Yeah, we close it later when you finish. Yeah. And you just make sure the first time your tube is straight. Yeah. Usually it is centered. Okay, but just in case.
In case.
We can stop it manually from there.
You can.
If there's a problem.
Yeah. So I will be there just in case. It says that I stop it. Okay, I fix it. But it's going to go very difficult to because it's already centered. Okay. Okay, so it's going to go up. The heatings, the very control here is just in the middle where the sample tube is. Okay, so it does not go all the way up because the element heat was in 0.1 degree, so it is very very sensitive. Okay, once you finish, you cover it. Okay, you have the large, and this is shape, and should cover very well. Okay. Maybe the reverse. It's very important because otherwise the heat will go up.
Yes.
Okay?
No good.
That's it. You're finished. You can also go. Let's go now to find sample file. We go sample file. New sample. Chemical absorption. You see here?
Yes.
Okay. Chemical absorption. Exactly the same as before. So the first is sample. Okay, the operator and submeasure and the sample weight, everything, and the comments. So everything's done there. Okay, go to analysis condition. Okay, also get the pressure as did before. Here we work with absolute pressure and that was relative pressure. That's the only difference. Okay, so we can go from 1 torr up to 760 torr. Okay, or millimeter of mercury is the same. Okay,
How many points do you choose?
Usually we take 10 points.
10 points.
10 points. Okay, so we go from usually at 400 torr is already done. Chemisorption is taking place at very low pressure. Okay, so start at 0.5 for example to 400 or 500 torrs and you finish.
Okay.
Okay, just this is starting pressure and put this as pressure increments.
And the equilibrium time.
The average set is always about 15 seconds.
15.
15.
Here also, yeah.
Okay, and then put increments. Just for example, 20 increments. Okay. Okay, up to 760. It's going to take for 15 seconds. Going to take 20, 20, 20, 20. But this is again here. It's going to depend on what, on how much the sample absorbs. Okay. With our reference material, we know how much it is. But if you don't know, it's maybe you have to play with 10, between 10 and 15 and 20. Okay. So if it's too much, it's going to take very little points. If it's too high, if it's too low, it can take many points. Okay, but usually with 20 is okay. Alright? Okay, so this you do there, and then you go to the free space is measured. Here the free space is evacuating. It's the same thing as the physical absorption, but you don't have the option to measure free space after. Why? Because the problem with the free space with gas absorption is a condensation of oxygen at 77 K. Here is room temperature, so there's no problem. Okay? Okay, so when you have the temperatures, here we have no P0. There's a difference. Temperature, this is the temperature also because we do it usually at the reaction temperature. This is 400-500 degrees C. Okay.
So we will put our reaction temperature.
Our reduction temperature, yes, is the first step. Okay. Yes. Then we can okay. Dosing. Yes, we can dose also, or you can have pressure. Doesn't matter, whatever you like. It's exactly as the Physisorption, but the dose also have to know how much it is. Because if dose too much, then you get only 3 or 4 points. Okay, it's better to put it as the increment pressure, not dosing, because we don't know anything about the sample. Okay. Termination is just backfilling like this. Okay, so go and finish with this one cancel. Okay, we need to fill is this to report the analysis. Okay, to the report. Okay, the isotherm. But we need to analysis let's condition please again. We need to find out where to repeat the preparation is what to repeat analysis. Okay. The repeat analysis is very important to click on the repeat analysis. What it's going to do is going to do the first analysis, the first adsorption isotherm as I showed you before. It's going to, once I finish, it's going to pour vacuum, okay, for certain time, evacuation for 1 hour. 1 hour too much, okay? Why? Because the Physisorption, the active particles could be on the surface, or could be inserted inside the support, okay? If it's on the surface, very strong, but if it's inserted inside the support, it's big, but it's still Physisorption. So 1 hour too much, I'll put 0.5, okay? So it's going to pull vacuum for 0.5, and then it's going to do exactly the repeat analysis under the same conditions as the first one. And at the end, it's going to make the calculation, the difference, and give you the difference in the adsorption isotherm automatically. Okay? All right. Then the report analysis. You will do exactly what you want. Okay? You can do the adsorption isotherm, the difference method. Okay, and the simple set is all different methods, but you have to do the first one and the second one. That's the most important one. Okay, at least. You like to do, for example, the method for Langmuir or Freundlich for the type 1 adsorption isotherm, you can do it also. Okay, but otherwise it's going to calculate it just linearly.
What about the temperature?
At that analysis temperature we see it there.
حطها مش
Analysis condition.
cancellation.
Here, temperature. Think of the temperature.
Okay.
Here.
So here inside the creative.
Okay. When we evacuate the sample from the sample, okay. Okay, first we have here the pressure. Okay, with the pressures, okay, we need to select the gases.
When you said that,
Yes.
this is the sorted.
Yeah.
Okay.
Okay. You select what you want. Okay, hydrogen for
Hydrogen.
example. Okay. Then this is the hydrogen. It's going to flow over the sample according to the pressure like this. First, we have to have the first step is the reduction of the sample. We need to on the sample the methods. The run conditions. Okay, this one here. Okay. No. Let's see what we're going to do. Okay, we need to find it here. The first step is reduction of the sample with hydrogen. Okay, it should be flow. Okay, the flow. This is for the analysis. On the preparations, see where the preparation is. Okay, it is here.
In situ activation.
Okay, here in situ
In situ
activation. This one here.
activation, yes.
Insert. Okay, it does insert which one? Evacuation. First, let's see. Wait. What you like to do is the first step is we need to evacuate the sample from any water. Okay, so you put evacuation, insert, and then they ask you for how long time or which temperature. So usually we do it for 30 minutes at 120 degrees. Okay. Rate 10 degrees per minute, always. Okay? All right. So okay. Now next step, insert. Okay. Next step is flow. So now we have the sample clean under vacuum. Now we're going to flow hydrogen. Okay. So flow to reduce flow hydrogen. The flow rate, well, 50 ml per minute is enough. Okay. The time we're going to do it at least for 60 minutes to make sure the sample to be reduced.
50.
Okay, time for 60 minutes. Temperature is usually a reduction for nickels or is about 400 degrees C. Okay, 400 degrees C. Temperature at 10 degrees Celsius, and a set internal trigger we don't have. Okay. All right. Now the sample has been reduced. Insert. Next step is just evacuate the hydrogen. Evacuation. The same thing as before. Evacuate for at least 1 hour. Okay. It's the same. Temperature goes at 35 degrees C or 40. 35 is very difficult. Well, here maybe we get 35 because it is cold. You don't have any way to cool it off because the air is coming is almost room temperature. If you have to put 0 degrees C, it's not going to go to 0. Okay, so more or less is about 30 degrees is good enough. Okay, so put 30 degree or 40, whatever is here. Between 30 and 50 does not change the result. Okay, then after evacuation, put insert. Okay, now go to soap or a leak test is important. Leak test. Okay, the leak test to make sure that the sample is completely clean from any hydrogen. Okay.
And the temperature should be at 40 also.
It's 40, it's the same.
Same.
Yeah. And the rate for 10 degrees per minute.
Okay.
All right. Okay, it should see that you have there for this. Now we can set the analysis. No, it should be set now. You should put it preparation. Insert and see what you have, what your analysis is. Okay, all right. Okay, then go to the next step. Here. Then after finish like this here, then start the analysis. The free space after analysis, evacuation time after analysis, okay.
With the temperature.
Okay. Is this 40 degree?
Close to 400.
No, now it's analysis at 40 degree. It's already the sample has been degassed at 400. Okay.
This is for the analysis.
Is it only for the analysis now here?
You can do it at any
Put the 40. Put the 40. He wants it on 40.
Okay. All right. Then you're gonna follow the dosing over there. Okay. And the maximum pressure is 9. The maximum time is 999. We need to finish. It is relative pressure tolerance 5%. Pressure for this is your tolerance, more or less 5%. Okay, which is good enough. Okay. So termination is the same. You can wait until cool off, or you can just take this. Just forget about it. Okay. If you wait for cool off, it's going to wait until cool off to 30, whatever, 50 degree, but it is already 50 degree, so it's going to start to finish. Okay? That's it. That's the only things we have. Okay? You have repeat analysis. Okay, the evacuation time 50 degree. That's the whole thing.
Sorry, Simon. Can you please just explain again about the repeat analysis, what it will do?
It will make the 20 mils, according to this,
Okay.
the first adsorption isotherm.
Okay.
We, in my presentation, said this is total absorption.
Okay.
The chemical absorption plus the physical absorption by the support.
Okay.
But I'm not interested about the physisorption. So after finish, it's going to apply vacuum and everything reversible is going to go out.
Okay.
Then we said that after 30 minutes, it will start again under the same conditions. We're going to start dose hydrogen according to the first one, and we get the second one. Whatever we took out is going to come back. Okay? And then the difference between them is the chemisorption.
Okay.
Is automatically done. Okay? You just have to select the pressure and then repeat the same analysis. Okay? Anything else? That's it. Then